Good morning, students. In the last class, we have discussed about the expanding the f of x as a Fourier series. If f of x having period 2 pi in the interval minus pi comma pi or 0 comma pi, and if the function f of x is even in minus pi comma pi or odd in the interval minus pi comma pi, we can write the Fourier cosine series expansion and we can write the Fourier sine series expansion. Right, if the function is even, then the Fourier cosine series expansion is given by in the of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos n x, where the coefficient a naught comma a n is given by a naught is equals to 2 by pi integral 0 to pi f of x dx and a n is equals to 2 by pi integral 0 to pi f of x into cos n x dx. If the function is odd, then the Fourier series becomes only having sine terms only. That's why it is called Fourier sine series. And it is given by f of x is equals to summation n is equals to 1 to infinity bn sin nx dx, where bn is given by 2 by pi into integral 0 to pi f of x sin nx dx. This is discussed in the last class, right? Yes, that is the Fourier series expansion of f of x having the period 2 pi in the interval minus pi comma pi or 0 comma 2 pi. Yes, we can write the f of x as a series expansion, that is called Fourier series, with the Fourier coefficients a naught, a n, bn. But in the last three classes, we have restricted the function f of x is a periodic function in the interval minus pi comma pi or 0 comma 2 pi. If we change the interval, that is not minus pi comma pi, not 0 comma pi, that means if we have the interval, another interval, we have another numbers for any x value, that is minus l comma l or minus 2 comma 2 minus 3 comma 3, that except these minus pi comma pi or 0 comma 2 pi, that is nothing but the function is not periodic function with period 2 pi. That here in that case, how we are going to expand as f of x as a Fourier series in the given interval, that is minus l comma l, we will discuss here. Now coming to the Fourier series expansion of f of x in the interval minus l comma l. Right, this is the lecture number 4. Fourier series for the functions having period 2 pi. So 2l. Fourier series for functions having period 2 into l. Up to now we have discussed about the Fourier series for a functions having period 2 pi. Now listen, Fourier series of a periodic function with period 2 pi was considered so far. Now consider the Fourier series expansion of a function and in the interval having the length 2l. Let f of x is a periodic function with arbitrary period 2l. I am taking l is a constant defined in the interval c less than x less than c plus 2 pi. In the last class, we have taken the x in the alpha less than x less than alpha plus 2 pi. Instead of 2 pi, I am taking the arbitrary value, arbitrary constant l. Here it is 2l I am taking. The remaining is same. C less than x less than c plus 2l. If you write the Fourier series expansion in the general for this l, c less than x less than c plus 2l, then the procedure is same. Now, first I am going to convert the Fourier series expansion in the interval c comma c plus 2l into into alpha comma alpha plus 2 pi by taking by introducing the new variable. Right, introduce new variable z, or simply I am taking z is equals to pi x by l, or this is same as x is equals to lz by pi, or this is same as z by 2 pi is equals to x by 2l. What is the reason for taking the new variable z? Now I am going to convert the intervals c comma c plus 2l as some d comma d plus 2 pi. That means with period. This is a periodic function of this is a f of x is a periodic function with arbitrary period 2l. By taking the substitution, I am going to convert the given periodic function with period 2l as the periodic function with period 2 pi. That is the reason I am taking the substitution. Remember, x by 2l is equals to z by 2 pi, or x is equals to lz by pi, or z is equals to pi x by l. Say this is equation number 2. Yes, when you are taking the new substitution, you should find the new limits according to the substitution. At x is equals to c, z is equals to pi c by l, right? That means z is equals to pi x by l. So z is equals to pi c by l, say, which is d. I am taking d, say. At x is equals to c plus 2l, z is equals to pi by l. Yes, x is equals to what I am going to substitute here, c plus 2l, that is pi c by l, l get cancelled, plus 2 pi. That means z is equals to some pi c by l plus 2 pi. Pi c by l can be taken as d, so d plus 2 pi. So what are the new limits of z here? Thus, as c less than x less than c plus 2l, with the new variable z lies in the interval d less than z less than d plus 2 pi. Is it clear or not? By taking the substitution, the values of x in the interval c comma c plus 2l is same as the values of z in the interval d comma d plus 2 pi or d less than z less than d plus 2 pi. So z varies in the interval d comma d plus 2 pi of length 2 pi. So that means f of x is equals to, f of x is a given function, no? X is replaced with what? X is equals to Lz by pi. So f of Lz by pi, which is equals to, I am taking this as capital F of z. Clearly, capital F of z, where z lies in d comma d plus 2 pi. Capital F of z is a periodic function with period 2 pi, right? So you know that how you are going to write the Fourier series expansion of a function, given function which is defined in 0 comma 2 pi or some d comma d plus 2 pi having the period 2 pi, right? You know that. Let the Fourier series expansion of f of z by using the previous knowledge or previous concepts. Right. Let the Fourier series expansion of f of z defined in the interval d comma d plus 2 pi with period 2 pi b. You know that capital F of z is equals to, generally you know that a naught by 2 plus summation n is equals to 1 to infinity a n cos n x plus p b n sin n x. Instead of x, what I am taking the variable here, z is a variable. Why? Yes, I have taken one new variable z to convert the c to c plus 2l as d to d plus 2 pi. And here it is. See, here it is f of x is a periodic function with period arbitrary period 2l. Here it is, when you are taking the substitution, z is equals to some pi x by l. Capital F of z is a periodic function with period 2 pi. Okay, so this is the Fourier series expansion. F of z is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nz plus b n sin nz. Say this is equation number 3, right? Where you know that by using this I am writing the constants, right? Here you know that by according to this, what I am writing, a naught is equals to 1 by pi integral d to d plus 2 pi f of z dz. But I am trying to substitute d and d plus 2 pi. Right, d is equals to, yes, d, what I, here it is, next I am going to substitute the d here, 1 by pi 1 by l. Yes, d is equals to, what is there here, d, what I am taken, d, that is pi c by l, say this is d. So the are better to write the new limit, the old limit c to c plus 2l, that is I am writing here. Yes, just if you replace z with x, no problem, you can change the limits, no problem. Right, here it is f of z dz, but you know that z is equals to pi x by l. Differentiating with respect to x on both sides, dz by dx is equals to pi by l. So dz is equals to pi l by dx. The dz is replaced by what? Pi a by l dx. Limits I am changing with as it is original limits I am taking c to c plus 2l. So here it is 1 by pi by l. Pi by l is a constant. You write that before the integration, that pi get cancelled. We have 1 by l integral c to c plus 2l f of x dx. This is a general formula for finding the first Fourier constant, that is a naught, when f of x is a periodic function in the arbitrary interval c comma c plus 2l. Remember this. In the same manner, I am writing a n is equals to 1 by pi integral d to d plus 2 pi f of z cos nz dz. But dz is equals to pi by l dx, so pi get cancelled, 1 by l will get. And if you are replacing z with x, function of x, you can change the limit c to c plus 2l. C to c plus 2l f of x into cos, z is equals to what? Pi x by l. N into pi x by l, that is nothing but n pi x divided by l dx. F of x into cos n pi x divided by l dx, where x limits from c to c plus 2l multiplied with 1 by l. It is a second Fourier constant, that is an. So this is equation number, here this is 4, this is 5. Now coming to bn, 1 by pi integral alpha to alpha plus 2 pi f of x sin nx dx. The same manner d to d plus 2 pi f of z sin nz dz. Dz replaced with pi by l dx and pi get cancelled, 1 by l integral c to c plus 2l f of x into sin n pi x n pi x divided by l when we are replacing z with pi x by l dx. Say this is equation number 6. Hence, the Fourier series expansion of f of x with period 2l. Hence, the Fourier series expansion of f of x with period 2l is, I'm writing in terms of x. F of x is equals to a naught by 2 plus, here it is plus missing here. Here it is a naught by 2. A naught is the summation n is equals to 1 to infinity. A n cos nx. Instead of x, what is there? N pi x divided by l. What is the reason for getting the n pi x divided by l? Divided by l, the function is defined in the interval c comma c plus 2l, that is the reason, plus bn sin n pi x divided by l. Remember, in the equation number 7, this is plus, this is a term here, we have the plus, right? This is the standard formula for the Fourier series expansion of f of x when f of x is defined in the interval c comma c plus 2l. C is any constant, that is c plus 2l with that is length of the interval is 2l. That is the reason I am choosing this 2l here. And a naught, a n, bn is obtained from the equation number 4, equation number 5, equation number 6. This is a standard formula. If I am taking, yes, here it is l is replaced with 2 pi. So what you are going to expect? L is replaced with 2 pi. Here it is n pi by x divided by 2 pi. Pi pi get cancelled. N pi x divided by l. That is case. L is we have L is equal to different value we have. So if I am taking if we write 2l is replaced with 2 pi. So we have a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus b n sin nx will get. Okay, this is a standard formula for Fourier series expansion of f of x, which is defined in the arbitrary interval minus l comma l, having the arbitrary period 2l. Right. Now I am going to use some. I am writing some results, important results. Let's see the different interval. Integral minus l to l cos m pi x divided by l cos n pi x divided by l dx is equals to. Yes, in case of m is equals to n is equals to 0. M is equals to 0, n is equals to 0. This is cos m pi x divided by l 0. Cos n pi x divided by l, n pi x divided by l 0. Cos 0 is 1, cos 0 is 1. Yes, 1 into 1, 1. So 1 into dx is nothing but x. Where the limits from minus l to l minus of minus plus l plus l to l will get. If m is equals to n but not equals to 0. M is equals to n not equal to 0 means cos m pi divided m pi x divided by l cos m pi x divided by l. So cos square m pi x divided by l by using the formula and expanding the finding the integration and taking the limits from minus l to l will get only l. Suppose if m not equals to n, cos m pi x divided by l cos n pi x divided by l dx. In the case of m not equals to n but not 0, in this case m not equals to n. So here it is not 0. In this case, you will get the integral value as 0. Right. You know, result 2. If both cos functions, if I am taking both sine functions, sine integral minus l to l, sin m pi x divided by l, sin n pi x divided by l dx is equals to. Yes, in case of m is equals to n is equals to 0, it is 0. Why it is 0? Sin 0 is 0, sin 0 is 0. 0 into dx is 0. Integral of 0 is nothing but 0. If m is equals to n and not equals to 0, in both cases, in this case also you will get l, in sine cases also you will get l. Yes, m is equals to n and not equals to 0, will get, here it is sine square m pi x divided by l by taking the expansion, that means by using the multiple and multiple angle formula, you will get, you find the integration and taking the limits from minus l to l will get the answer is l. Next, result 3, it is very easy to remember. Sin m pi x divided by l cos n pi x divided by l dx is equal to 0 for all integers of m and n. One is sin, one is cos. So that is the integration value is 0. But in this case, if you have the limits from minus L to L, yeah, the expansion like this. Okay, this is the Fourier series expansion of f of x in the interval c comma c plus 2. Suppose if the function is even. In the last class we have discussed same. I am trying to recall the information from the last class. The Fourier series expansion, Fourier series for even and odd function. Let f of x be a even function in minus L comma L. Then the Fourier cosine series expansion is what? Yes, summation if f of x is equal to a naught by 2, summation n is equal to 1 to infinity a n cos n pi x divided by L. Right, why here it is a even function bn cos n x. Bn cos n x in the integration, you know that based on the previous information I am writing this. Where a naught is equals to 2 by L integral 0 to L f of x dx. As it is, instead of 2 by pi, here it is 2 by L will get. 0 to pi we have, here 0 to L we have. A n 2 by L integral 0 to L f of x into cos n pi x divided by L. Only sin cos n x is there in case of previous class. If f of x is odd function in minus L comma L, then the Fourier sine series expansion of f of x in the interval minus L comma L is given by f of x is equals to summation n is equals to 1 to infinity bn sin n pi x divided by L, where bn is equals to 2 by L integral 0 to L f of x into sin n pi x divided by L dx. This is a bn. Remember, when the function is even, this is the expansion and the coefficients are given by a naught and a naught, an. If f of x is an odd function in minus L comma L, then the Fourier sine series expansion is, this is the Fourier sine series expansion and the constant Fourier constant is given by 2 by L integral 0 to L f of x into sin n pi x dx. Now we are taking some problems, right? Remember, the students remember, yes, the problems on Fourier series is completely depends upon evaluating the integral. That is the reason I am choosing this platform. Again I am telling, if you are finding the integration properly, you will get the Fourier series easily. Otherwise there is a problem, right? Here it is very easy chapter. If you know the formulas a naught, a n, b n, you will get the constants and substitute a constant in the expansion. That is the required Fourier series, right? Okay, that is the reason I don't want to solve as much of as many problems. Right. Just I am trying to do one or two problems. So just please listen. Find the Fourier series expansion of f of x if f of x is equals to 2 if x lies between minus 2 comma 0. If f of x is equals to x if x lies between 0 comma 2. That means the function is defined in what? Minus 2 to 2. Right? It is defined in minus 2 to 2. So I am going to find the Fourier series expansion for f of x. It is neither even nor odd. So definitely you are going to find a naught, a n, b n. So the Fourier series expansion for f of x in the interval minus L comma L, this is the formula, right? A naught by 2, here it is plus a naught by 2, summation n is equal to 1 to infinity a n cos n pi x plus b n sin n pi x divided by L. Here L is equals to 2a. Right now I am trying to find one by one a naught, a n, b n. A naught is equals to, the formula is 1 by L integral c to c plus 2a f of x dx. So 1 by 2 minus 2 to 2 f of x dx. But the function is defined in the two piecewise continuous, right? The function is piecewise continuous. In minus 2 to 0, the function value is 2. 0 to 2, the function value is 2. That's why we say that it is piecewise continuous, right? Here it is 1 by 2 integral minus 2 to 2 f of x dx. So it is 1 by 2 integral minus 2 to 0 f of x dx plus 0 to 2 f of x dx. Minus 2 to 0 function value is 2 and 0 to 2 function value is x. Minus 2 to 0 2 dx, 0 to 2 x dx. Right, 2 dx it is nothing but 2 into integral dx is x. If you take the limits, x limits 0 minus or minus plus 2. So 2 into 0 plus 2. Integral x dx is x square by 2, that is 1 by 2 into x square. If you write the upper limit, 2 square is 4, 4 minus 0, right? 4 minus 0 by 2, that is 4 by 2, it is 2. 2 into 0 plus 2, 2 into 2 it is 4, 4 plus 2, that is 6 by 2, it is a naught is equals to 3. Similar fashion, yes, here it is a n formula, 1 by L into integral minus c to c plus 2l, that is minus 2 to 2 1 by 2 into integral minus 2 to 2. Here it is yes, c is equals to minus 2. C plus 2 c plus 2 is what? Minus 2 plus 2 into 2. First, don't get confused here. This is the general formula. C plus 2 c is equals to minus 2 plus 2 into 2, that is minus 2 plus 4, that is 2. So minus 2 to 2 f of x into cos n pi x by 2 dx. Right. Here it is 1 by 2 into integral minus 2 to 2 minus 2 to 0 f of x is equals to what is there? 2 into cos n pi x by 2 dx. Right. Plus 1 by 2 integral 0 to 2, the function value is 0 to 2, function value is x into cos n pi by x by 2 dx, right? Let's see, it is 2 cos n pi by n pi x divided by 2, integration is what? Sin n pi x divided by 2 divided by n pi by 2. This is very important, right? Yes, I have not written here. Cos n pi by x, this is a constant. Integral cos ax dx is sin ax divided by a. Integral cos n pi x divided by 2 dx is sin n pi x divided by sin n pi x divided by 2 by n pi by 2. Yes, where the limits from where to where? 0 to minus 2. If you take the x limits are 0, sin 0 is 0. If you take minus 2, sin of n pi into minus 2 divided by 2 to get cancelled, n pi it is also 0. If you take this term is completely 0. Only this term we have. Yes, x into cos n pi x divided by 2. You go for the integration by parts. Already we discussed. Yes, that is the reason the evaluation process is very important. If you are finding the coefficients in the right way, right, the Fourier series expansion is over. Yes, UV applying UV, and after taking the limits from 0 to 2, you will get an is equals to minus 4 divided by pi square n square. When n is odd, what is the reason here? When n is even, you will get n cos n pi will get here. So when n is even, will get the quotients becomes 0. N is odd, the quotient becomes minus 4 divided by pi square by n square. Next, Bn is equals to, this is the formula. Bn is equals to minus 2 to 2 f of x sin n pi x divided by 2 dx. F of x is equals to, you take 2 if x lies between minus 2 to 0, and 0 to 2 if x lies between 0 to 2, the function value is x. In the same fashion, if you find the Bn, as please verify whether these answers are correct or not. It is clear a0 by 3, a0 is equal to 3. Yes, if you find the integration in the right way, you will get a0 is equal to minus 4 by pi square n square when n is odd, otherwise n is even, it is 0. Right, Bn is equals to minus 2 divided by n pi. Right, if you are substituting these in the expansion, f of x is equals to a0 by 2, 3 by 2 minus 4 by pi square, summation n is equals to 1 to infinity 1 by n square cos n pi x divided by 2 minus 2 by pi, summation n is equals to 1 to infinity 1 by n sin n pi x divided by 2. Here it is if you take even, here it is if you take n is equals to 2, is cos n pi x divided by 2 by 2. Alright, here it is even number of n, so you will get the value is maybe that means even for even the terms we don't expect the terms, right? This is a Fourier series expansion of f of x, which is defined in the form 2 for minus 2 less than 0, x less than 0, and x for 0 less than x less than 2. Right. Next, we take another problem. F of x is equals to, try to solve this problem. F of x is equal to x square in minus L comma L. Yes, by expanding this, if you are applying this procedure, you will get a0 is equal to 2 by 3 L square. An is equal to 4 L square by pi square n square minus 1 to the power of n. Yes, f of x is equals to, what is the reason only a0 an here? Why it is a even function? It is a even function in minus L comma L. Just you are going to find a0 an. L is not fixed, it is arbitrary. That means yes, if f of x is given, f of x is equal to x square in minus 3 comma 3. Yes, you can take this as the formula, right? So a0 is equal to what you are going to get? X square 2 by 3 into 3 square. That is 2 by 3 into 9. It is 6 will get. An is equal to 4 into 3 square divided by pi square n square minus 1 to the power of n. Right? So finally you will get that this is a Fourier series expansion of f of x is equal to x square in minus L comma L. Okay. Class we go for the half range cosine series, half range sine series in minus L comma L. I will give some problems on this today's class, and next half range cosine and sine series problems. This is very easy and simple chapter. Problems, you don't worry.